Polarizing materials is how you make magnets and electrets. In order to move beyond simple plastic electrets, we need to understand the manufacturing process of each. So let's go over magnets. So with magnets, it's very easy. You make a mold of any material with a ferromagnetic substance in it, and then you align all the polarities by putting another magnet to it, which makes it a magnet, and then you hit it with a huge pulse, and the pulse welds the polarization into the material. Now, this means that the material that you polarize is very important, the most important thing that you can think of. So let's do magnets first, and then I'll come back.
Then, the tube is unsealed and the rings are carefully removed. They go into a machine that applies a magnetic pulse of up to 3 Teslas. This pulse locks into magnetic domains, permanently.
And why does the pulse lock in the magnetic domains? Because it welds them. The metal gets induction from the huge pulse of magnetism, and when it does, it gets hot and it welds everything in place. Now, when you do this with electrets, with plastic, it's different because you need to polarize it and then lock it in place. So with plastics, there's a different process. With plastics, you have to get them melty. So once you get them in a melted state, then you can apply an electric field to it, and magnetic field in this case, and that will polarize the material. If you let it sit that way, then the polarization will lock in place and you'll get an electret, which is like a magnet, except it has a permanent electric field. Okay, so let's watch real quick and see Plasma Channel do this.
This was pretty interesting. When molten, the polyethylene turned crystal clear and had the consistency of cold honey. Not quite pourable, but liquid enough.
Now you see he puts the magnet on top of it so that the magnetization comes down here. Now think about the magnetic field will be looping around like this, right? And it's cutting straight through the material that he wants to polarize. Now, on the inside of here, he's got a piece of copper tape on the top and a piece of copper tape at the bottom. And then through the back, you can see he's got negative hooked up down here and positive hooked up here. And now what happens is he turns all the electricity on while it's goopy and locked in this mold, and it locks the polarization in place.
It's holding up okay, but the separator, the insulator, melted off. So it's about to melt into a puddle. A few hours later, I was greeted with a really beautiful sight, a perfect little hockey puck of electrical doom. It formed perfectly, and I could feel the hair on the back of my hand.
And as you can see, once cooled down under the effects of the other polarizing materials, meaning the electric field and the magnetic field from that huge magnet, you get this beautiful little hockey puck that has a permanent electric field around it, not like a magnet with magnetism, but an electric field, static electric field, just like what you have like when you rub the balloon on your head or in your blankets, or what reaches out and touches you whenever you get zapped by a doorknob. The same thing as that. Okay, so then what becomes most important is the material that we choose. And while plastics were chosen here because, you know, they're an insulator and they've been done before, there's no reason we can't do stone. And so think about the cement and how it dries. Okay, you have it in a goopy form that can be manipulated by magnetism and static electricity, and then it slowly cures over time. So if we make a mold just like what he has here and let cement, or we can do things like Marcel has been doing online, and we can use certain materials to make a slurry of whatever chemicals we have. And then as it cools over time, as it cures over time, we can expose it to polarization and let the polarization lock in place. And then we can get some really exotic fields. Now, what do I mean by exotic fields? I mean, we could get dielectric fields that quench all electricity when they're exposed to any electronic device. Think your phone just shuts down or your car just turns off, all because it was exposed to a field just like what's around here, except different. You could also have diamagnetic fields, which cancel magnetism or reverse magnetism, and that would be really useful for a lot of, obvious reasons. So ultimately, though, I think that there are two paths to electricity, one through magnetism and then one through static electricity. And I think the ancients, how you explain all of these massive structures all over the world is they got there through static electricity and polarizing stone, not metals like we use today. Because stone is just as hard as metal in most cases. But, if they could form and manipulate it and polarize it, then you could put crystals and, crystals which hold charge against insulators, which keep it in there, and then charge it up and polarize it over time, and it would just hold electric fields. There's a lot of things that are possible if we learn how to polarize stone. So if you like this content and you're a free thinker too, hit the like button, subscribe, and let me know what you think in the comments.